At 1:15. Hello, everybody. I'm Dan Powers. I'm the Executive Director of CoLabs, a consortium of federal research laboratories and joint research institutes in Colorado, and our broader ecosystem of technology companies, economic development organizations, academics, anyone who is interested in science and the discoveries happening here in Colorado and how they're manifesting out into the country. Our mission is to describe the ROI of taxpayer-funded research and help ensure that these federal labs stay funded and stay here. So as part of that mission, we look to connect the scientists in Colorado with the general public and elected officials, make sure there's an audience understanding what they have going on. And the storm coming in to Colorado this weekend has really been on a lot of people's minds. Everyone's been referencing it at the end of their emails, it seems, during this week, or it's brought up in the Zoom calls. So we have made a connection with the National Weather Service, the chief scientist. Actually, I'll let you describe your bio a little more in detail, Paul, but we're hearing from Paul Schlatter today. And let me give a little bit of background. Paul is the Science and Operations Officer at the National Weather Service Forecast Office in Boulder. He's been with the National Weather Service for 18 years and the last 5 years in the Boulder office. He's actually a Boulder native, graduated from Fairview High School, just up the hill there. And he's the son of a retired meteorologist who also worked at both the National Center for Atmospheric Research and the National Atmospheric and Oceanic Administration. So he also spent time working as the chief of staff in Maryland at the National Weather Service headquarters. So I'd like to, with that background and perspective, your awareness of the technology and all of the nuances and the threads that need to be connected together to make an accurate forecast, your insights is going to be wonderful to hear. So Paul, let me turn this over to you, and everyone on the call will take some questions in the chat function as we go along, and I'll try to moderate those as we get towards the end. But please, let me hand this over to you with just the idea of how do you really know what is about to happen to Colorado? Should people, what should they understand? And then we'll get into some of the backstory of exactly how it is that your team comes together with this kind of forecast.
Yeah, first, let's look at how lucky we are to be in Colorado. Look at that. Wait for it. So you're seeing cloud bases. That the Flatirons are sort of there, but gosh, what a place we live in, right? And the weather we get to experience, especially this time of year in the transition season where we're going from winter to spring. We get some of the best storms in March, so this weekend is no different, really. So the question is, how do we really know? We don't really know. I'm sure that's not a mystery to most of you on the call. We play, and I'm not going to call it a game, but we definitely have to work through all the different scenarios that are possible, and then message that uncertainty as to what's going to happen to our partners, to the public, to everyone we interact with. We try and message just how uncertain we are about what's going to happen. But in the end, our partners and our users want an answer. I mean, they want us to give them our best estimate for what we think is going to happen. And so, gosh, we use everything at our fingertips to try and get to as best an answer as we can get, as far out as we can give that answer, and then try and convey just how uncertain that forecast is.
All right. Maybe it would be helpful. Could you give us the latest? What is the forecast right now for perhaps all of Front Range of Colorado? In fact, that might be part of your answer could be, how do you decide what type of regional forecast that you make? Someone in Fort Collins, for example, who's on this webinar, are they really going to be needing to understand what's happening in Denver? What's the distinction there?
Yeah, I'll share a screen here so I can show you, because I will always defer. Let's see this side, share. Here we go. Is everyone seeing a snowfall page?
Okay, yes, I can see that.
Okay. All right, so let me enlarge it. There we go. All right, this is actually going to change in another hour. And I don't feel I'm perfectly comfortable telling you all what we're going to update in the next hour with this particular snowfall forecast. So this was this morning's forecast based on every available guidance that we have at our fingertips. And the models are slowly inching the parent part of this storm system, that's the mid-level circulation, the shortwave trough, we call it, edging it so ever slightly north, which that's good. That's good if you really like snow for Larimer County, anywhere in Fort Collins metro area. Obviously, Wyoming, if you love snow, Wyoming's going to get hammered the further north this storm seems to track. But some of the issue with the northerly storm track, two things happen when a storm goes further north or trends further north. Two things happen in Metro Denver and even in some sense of Boulder. A dry slot occurs on the south and southeast part of the storm. So in general, this area, we may be trending those amounts down a little bit. So we're talking Metro Denver. Boulder's probably still going to be in some of the heavier snow, but from just south of Denver and points east, that dry slot could affect amounts because the storm's trending further north. The other thing that happens with a more northerly track for Metro Denver and parts of Boulder, and especially out here on the Eastern Plains, the further north that storm goes, the more the surface winds are out of the southeast instead of east or northeast. As we know around here in Colorado, southeast winds bring what? A little bit warmer air. So rain and a little bit warmer temperatures may be inching their way further east. Not necessarily, Denver's going to see mostly snow. We're still confident in that, but some of these areas out here may see a little less because it's a little warmer and it's a little further north. Again, all these things can change. But what we are very confident in are the amounts for Larimer County. Fort Collins, and especially the foothills west of Fort Collins up Highway 14, lots of snow to be expected up there, 2 to 3 feet generally. Foothills west of Boulder, also generally 2 to 3 feet, a little less than the northern foothills. Boulder could still see up to about maybe 20. Denver, we're trending down towards 12 to 18 for most of Metro Denver. So we'll see. But hot off the presses, this will be updated in about an hour. That's what we're looking at right now.
All right, Paul. So now back up. What was happening 5 to 7 days ago? And can you get into some of what are the technology, the modeling that you use to start to assess what's about to happen, or what's coming together at that point?
Yeah, what's coming together? So roughly 5 to 7 days out, we are issuing official forecasts for that time window. And we rely heavily on Ensemble forecast systems.
Excuse me, Paul. You're not on camera. And
what's going on here? I said start video. Is it my? Are you seeing a
there
screen?
You go.
Okay, now you see it.
We did for a second.
Give me a second. You can hear me though, right?
Definitely can hear you.
Oh, come on, come back.
I just know I'm not the right image for a climatologist or meteorologist.
I'm trying. Right, I'm trying. I said bring it back. Let me try this again.
That's okay. Your expertise is not in Zoom; it's in weather forecasting.
And we use Google Meet too. That's our platform. I wonder if it's the screen sharing that I messed up. I'm just glad you can hear me. That's good.
Well, then tell you what, if you don't come back up, put up another image that you think is relevant.
Yeah.
And you can answer the question.
Yeah, give me a second to do that. Oh, I'm back. Okay, good. Very good. All right, 5 to 7 days out, we're using mostly Ensemble forecast systems to do the forecast, to analyze what we think is going to happen, say, for this weekend, 5 to 7 days out. What were we looking at? It's all global models, because that's what we have access to. We use the Euro, we use the Canadian, we use the UK Met, we use the GFS, obviously, and all the Ensemble systems of those various platforms. And we do that because it's so far out, Ensemble systems are superior to any one single model. And it also gives us an idea of how certain or uncertain a particular event is unfolding. So we're able to convey that in just general messaging. We can't in good conscience put out a snowfall amount that actually shows a point value across the state of Colorado that far out because the uncertainty is just crazy. Also, think about it. Is that doing the public a service? And I use that as an example because if any of you are on social media starting Sunday, I think everyone, because my neighbors are even telling me, oh, I saw that forecast of 80 inches for Boulder. Well, they just assume either the Weather Service issued that or it was a human forecast. But in every single case, that was a single GFS model run that was consistently showing about 80 inches for Boulder. And then people were tweeting that and Facebooking it and putting it out on Instagram, and everyone was seeing it. Oh my gosh, a huge storm's coming. So in the Weather Service, we fight uphill battles all the time against that tidal wave of social media posts that just show a ridiculous, epic, record-breaking storm occurring, but it's a single deterministic model. If they would have posted the Ensemble output, they would have seen, okay, yeah, the deterministic model is pretty high, and the Ensemble mean was actually quite a bit lower. But there was a significant amount of members that had nowhere near 80 inches. Some of them, a lot of them did, and even more. On top of that, the other guidance we use, like the Canadian ensembles and the Euro ensembles, didn't have that much. So we knew, based on our full analysis, that 5 to 7 days out, that would be silly to put something out that big. And we refused to do it. There's too much uncertainty. And I think it does everyone a disservice posting something like that when it's so ridiculous that far out. But that's the challenge we face 5 to 7 days out. And we're very happy to have these ensemble systems that help us get to that right level of messaging so that we're being responsible about what we're sending out to the public, to our partners, and that kind of thing 5 to 7 days out. In general, we're not briefing partners that far out, not for a winter storm. We usually wait till a little bit closer, and we'll get into all that soon.
All right. So then we start trending a little bit closer when we're more like 3 days ago. That's when I didn't hear so much 80 inches, but definitely we're hearing like 3 feet, 4 feet, and in the mountains. So then what type of modeling, and if this is where we start getting into the HRR technology, definitely wanting people to hear more about that.
Yep, we're getting closer to HR, and that's what I'll show once we get to the 1 to 2 day range. But in the 3 day range, we start our briefings. We started them Wednesday, so today's Friday. So yeah, that was about 3.5, 4 days out. For a storm this big, we like to give our partners as much as a head up as possible. We also did something that's a little out of the ordinary, where we because we were briefing partners, we made some storm total snow graphics, again based on our interpretation and analysis of all available ensemble systems. And I mean, we slanted towards the Euro solution because it had been the European solution, the ensemble solution was so consistent. It was always saying between 1.5 and 2.5 inches of liquid across the area. That was reasonable. We were good with that. So we kind of slanted our forecast towards that. The reason it was a little out of the ordinary to share a snowfall graphic that was at 4 days before at least 3.5 to 4 days before the first flakes came out was officially, we don't even issue snowfall official forecasts until 72 hours out. And that's to the start of the event. So we did a storm total event for even way beyond that. The reason we did that was, 1, to combat the social media beast that had grown over the previous days. 2, that's our partners want it. I mean, we are here to support our partners, and they wanted a storm total forecast, so we got that for them.
Interesting.
That started 3 to 5. Go ahead.
And could you clarify? I'm just seeing some questions that come in. When you reference ensembles, that's just a reference to that whole group of different models that you pull together, and then you refer to it as ensemble, as whatever that aggregate is.
Yeah, let me explain. There's 2 different ways that we use ensembles. The first way is just the pure ensemble of the system, where, let's say, the global forecast model for the US, the GFS, it's got 30 different ensemble members. And all that is they tweak the initial conditions, then run the model using the same dynamic core, same physics, get a solution, then do it 30 different times. And so we have 30 different possible outcomes to draw upon, possible solutions to draw upon. You can do the mean of those values. You can look at the outliers. You can look at clusters. There's a lot of different ways to dissect, slice and dice ensemble systems. They do that for the Canadian Euro. So that's how we use that ensemble system. The Weather Service generates a super ensemble called the National Blend of Models. What that does is it ingests every single ensemble member that's out there. We're talking 170 different inputs at each forecast step as we get closer in time. We do that because the statistics have shown if you're using the best of each model, the best of each ensemble system, you typically get the best results in a particular forecast. For our official forecast, our starting point is the national blend of models. And then as a forecaster, and this is 7 days out, as we get closer, well, obviously we're tweaking the forecast a little bit more. But as a human forecaster, working in Colorado, we've got staff that have been here, lived here, forecast here for a long time. We're very deliberate about where we change the national blend of models forecast. We look for what we call targets of opportunity. Where can the human add the most value to the national blend of models forecast? And we're doing that all the way up to, we're still doing it today, making sure that what we think is going to happen is reflected in the forecast. But the national blend of models gives us a really good starting point because it's national. It's the same starting point from the same forecast system that every office across the Weather Service starts from. So it's a really neat way to start the forecast, and then we tweak it with our local expertise. But
Nice.
again, that's throughout the whole process. We're doing that for the whole time. So those are the two different types of ensembles that we use in the forecast.
Okay. All right. And so now we're edging back into more of that 3 to 5 day out before we get into the even more nuanced, but fascinating. As going back to what you referenced, you did something a little unusual to put out information because what you were seeing in social media was just starting to get too far afield of what you and your colleagues were seeing as the more likely scenarios.
Yeah, think about it. People want to know how much snow is going to fall, so they're going to get it from when whoever is putting it out there. They're going to look at that and interpret that and apply it personally to themselves. So rather than just staying silent until 72 hours before, when we can officially issue some official forecast for that time range, we figured get out there, because we feel like we had a pretty good handle at that point on generally what to expect. So why not share that information with everybody? We know there's some skill in that, and they're going to look at it anyway. So why not get it from an official source that hopefully knows what we're doing?
Mm-hmm. All right. So then a bit of that backstory there. What additional modeling or technologies, protocols do you start to bring into bear 3 to 5 days out?
Actually, it's all about the same. Actually, for this particular storm, it became even a little bit more uncertain the closer we got, which is fascinating with this type of event. The uncertainty in certain areas, like I showed southeast of here, Denver and southeast, the uncertainty's actually gone up since earlier in the week there. But really, we're looking at the same things, but only with a little bit more confidence in what we're seeing, partly because by this time, the storm is being sampled by the U.S. Upper Air Network. Aircraft soundings are sampling that storm. Surface observation ships. It's actually being much better sampled now than it was when it was farther out over the Pacific. Nice. So in theory, we have a little bit more confidence in what the models are showing 3 to 5 days out.
All right. And yet getting more complex or more confusing, you said. Give us some examples. What were you seeing that started going left or right when you weren't expecting it?
Well, subtle shifts in the position of the 700 millibar low, that's roughly 10,000 feet, and the 500 millibar low, which is roughly 15 to 17,000 feet. You move those 50 miles this way or 50 miles that way. That makes a massive difference in the strength of the easterly upslope flow that then, oh boy, hold on, give me a second. There we go, I'm back. That will influence the strength of the upslope flow as it rides up into the Rockies. The other thing is the position of those lows also determines how cold it's going to be. Now in the foothills, it was always going to be snow, so the uncertainty in the foothills was very, very minor. But on the far eastern plains, we know it's going to be warm enough for rain. Where does that rain snow line set up? How far west does it go? Because even if you're near the rain snow line and snowing, it's going to be so warm it may just barely accumulate on the grass because you're warm. So there's that whole transition zone. Where is that going to set up? And we're watching. So the global models come in every 6 hours. The Euros every 12. 3 to 5 days. We are sitting on pins and needles as each new model run comes in every 6 hours, analyzing, okay, what's changed for this run? Is the upslope stronger? Is it out of the southeast instead of the east-northeast? Where's that surface low going to be? All these things we're trying to integrate together in this window here and seeing how it's evolving over time.
All right. So now, let's say within the last 48 hours or even jump to just since you all have arrived at work today, I see you're at work. Give us an idea. What is it like for you in these hours now, where presumably within 12 or 24 hours of a storm? What is the activity like there in the office? How do you all coordinate and communicate with the data that's coming in?
Yeah, I mean, it's obviously busy. Now that we're 24 hours or so from the start of the storm, however you want to define that. We have more tools in our arsenal, which is nice. We have the high resolution rapid refresh. That's the HER model, developed literally just down the hall there, just down the hallway.
Mm-hmm.
Tens of fantastic modelers down that hall. They've been working for, gosh, since I was a kid, since I was in high school. They were working on versions of this model, improving it all the way since the mid 90s. My dad was involved with some of that. That model runs out 48 hours. And in a lot of ways, it's a game changer in terms of the resolution it provides and the things it can model well across our area. For example, it is very good at predicting upslope and the strength of the upslope flow and the moisture involved with that upslope flow. From this point on, we still look at the global models. We look at them the entire time because it gives us a broader scale picture of what the weather patterns might be. The HER helps us zero in on, okay, if there's going to be a snow band set up. And in this one, we're not expecting like a narrow band like we had in February. But the HER is one of the only models that can accurately forecast, within a few hours of being right in time and within 10 to 20 miles, sometimes 30, in location of where that band would be. The HER gets us there. And just having that partnership with the NOAA labs just down the hall, and I know they value the partnership we have with them because we email each other all the time. Myself and other forecasters are emailing the modelers down the hall saying, hey, your model might have an issue in this little area. Is there any chance you could look at it and see if there is an issue there? Or are we just imagining things? And more often than not, they'll find a minor issue, then fix it in the next run. And, a few weeks later, they fine tune the model again. I can't say it stinks in COVID not being able to do that in person. So we do it over email, which everyone has to go through that. But that type of partnership between research to operations has just been fantastic. So that's the HER model. That's helping us zero in on, okay, where do we think the heaviest amounts are? And if I show you, gosh, I don't want to lose my camera, but let's do it anyway. I'll show you the latest forecast of the HER, just to give you an idea. Here it is. All right, you seeing an animation?
It's not up yet.
All right, let me see what I did wrong. Oh, I didn't hit share. Now it's going to show up. Not that one, this one. All right. Now we seen it?
Yes.
Okay.
Right.
So this is a product that we really like in our office. And only the HER model provides it. It is the run total accumulated snow depth. So as soon as the model run starts, which was 12Z or 5 a.m. this morning, it goes all the way out to 5 a.m. Sunday. This is the 48-hour forecast. It uses a variable density snow ratio by it trying to account for temperatures in the precipitation production layer, and then assigning a snow ratio, which is liquid to snowfall in inches ratio. And we found that this does the best for just about any type of snow regime. And in this particular case, we'll see heaviest amounts right at the top there. Cheyenne, we kind of knew that. North of Cheyenne is probably going to get the most out of this. But it is showing some pretty high amounts in the northern foothills. In Larimer County, that's 24 to 38 inches, that pink color in there. You also notice the HER is picking up on some of that uncertainty. Notice it's only green from about Greeley southeast, and green is that 4 to 6. Now we're not necessarily, and that we do know that's because the HER is one of the warmer models. We haven't bought into it yet in terms of it being that warm, such that only 4 to 6 would fall in Weld County. A lot of times, again, this is using human input forecaster experience. We know that the HER can sometimes be just a little bit too warm in events like this. And so that's why I think this will mostly be snow rather than mostly fall snow rather than rain snow mix. We'll see, but these are the types of things we go through. And the HER makes that possible. It helps us zero in on where we think the heaviest snow is going to be. All right.
Right. Can I ask you a question, a couple questions
Yes.
that have been sent in here? What's the typical cell size used in the best current meteorological models?
Is that grid resolution? Is that what he's asking, I think, or he or she?
So, and I'm not sure, or unless cell, well, you might know better. I'm not sure what the reference is to cell.
I'm going to go with resolution. Yeah. The HER is 3 kilometer horizontal resolution. That's the highest that we look at. I know my screen's it's still not showing me. There we go. Guess it just takes a minute. Yeah, so the HER has the highest horizontal resolution of 3 kilometers. The GFS and EC global models, they're getting down to 12/13 kilometers, that range, which is really good. And I know the Europeans are going to drop that even further, which is great. That's about those are the main models that we use in terms of resolution. I hope that answers that question.
Yes, he confirmed he was asking about grid resolution. How about a question or to what degree is multi-scale analytics a part of overall modeling?
So we do use, that's a good question. The national blend of models it's all statistical analyses. There's weights applied to each of the inputs based on past performance. There's bias correction applied to each of the inputs. And then it spits out a forecast. So heavily weighted that way. And then for the Ensemble systems, we do use not as heavy statistical, but we use certain things called clusters in the Ensemble systems where it compares each of the solutions, and if the ones that are similar, it groups together, and then maybe some others are similar in a different way, and it groups those together. And that helps us see just the different types of possible solutions there are. So in other words, if half the ensembles have the storm in northern Colorado, the other half in southern Colorado, we can say, well, it's equally likely in this case that it's either here or here, based on that cluster analysis that we do. I'm not aware of, or I may not have access to the types of multi-scale statistical analysis that he or she is asking about.
Okay.
We work with whatever we're given. It's a good way to put that.
All right. That might be for another call, exactly talking to the modelers.
Yeah.
All right. A couple of questions. I'm looking at the time here, and I know you have plenty you need to get back to analyze and get the new news out to us. Another question is, how are post-storm snowfall amounts used to evaluate models and forecasting for future similar scenarios?
Quite a bit. Yep.
You double check in essence. Here's what we thought was going to happen. Here's what really came down.
Yeah. I mean, officially that's done at the national level, but for the local level, we definitely look at that because we're always looking for ways to improve our forecasting at the local level. Nationally, they do it because they're evaluating the GFS. The Euros are evaluating their model. We evaluate the national blend of models because that massive system also spits out snow amounts. So we're always verifying to those things. And so I hope we get as many snowfall reports as we normally get in a storm like this. We bring in anywhere between 300 and 400 storm reports. So anyone on the call, feel free to call us if you have a yardstick and are ready to measure, because we will use every report we get to help verify. And the more the merrier.
Describe that. Yeah, describe that a little more. How would people who are interested to help be part of the assessment, how do they do that?
I will show exactly how to do that. Screen one, share. Let's go here. So right at the top of our webpage, weather.gov/BOU. You're seeing that, right?
Yes.
Okay. Current hazards. Submit a storm report. Click on that.
Okay.
This is the easiest way.
That first URL you put up was in the Zoom invite. So
yeah, weather.gov/BOU. Yep. And then submit storm report. Real easy. So also we take your phone calls too. I mean, you can call us at 303-494-4479. That'll directly get to us. You're on the phone with us for 30 seconds telling us where you are, how much snow you got, when you measured it. Pretty simple if you want to go that route.
What'd you say that number was again? I'm going to put it in the chat here.
303-494-4479.
4479. Okay.
All right, let me go back. And I'll just be patient. My camera comes back in like 10 seconds, so we'll just wait. But okay, other questions?
How about, you had mentioned before, as we get closer, there's aircraft and types of drop sounds that are used. Could you give it just a quick description again? I was curious to what extent there's the whole satellite and low Earth orbit type of assessments, all the way down to, you mentioned on the ground, but what is that almost checklist of different types of technologies that are used to help provide the data that you end up modeling
Yeah,
with?
very good question. Yeah, so from about today through the rest of the storm, we're looking at anything we can get our hands on, but satellite is huge, especially the geostationary. The polar orbiters are huge because they provide so much valuable input in the vertical for the models. Now, we don't look at those. Gosh, my camera's still not up, is it? I don't know why it did that. There it goes. There we go. The low Earth orbit satellites, we don't look at directly in the forecast office very often because they only make passes every so often. But gosh, they're huge for forecasting because they are the primary driver for input into the models. We're also using aircraft observations. Those are also very valuable to the models. But we do look at individual soundings from flights that take off or land from DIA, because that gives us vertical profiles of temperature, and some actually provide moisture. Some have good winds attached to them as well. In between our soundings, which are 12Z and 0Z with 5 a.m., 5 p.m., it's great to see how the temperature profile is changing over the Denver area based on those aircraft observations.
Right.
We have access to NOAA's profiler. There's I forget what frequency profile, but anyway, it's located near Platteville, Colorado. Fantastic place to study upslope because it's right, it's right in the middle of the kind of the South Platte Valley with the mountains just to the west. So if we're seeing upslope winds 2 to 3 kilometers off the deck that are like 30, 40, even 50 knots, we know we're going to start to see, or already seeing, some really intense snowfall rates just based on the vertical profile of wind. So that's a fantastic thing that NOAA provides us. Obviously, radar in real time. We're looking at radar to see where the heaviest snow is. The mesonet, also very important, and we'll take obs from anywhere. We get backyard observations, which are great. And then, as I mentioned, submitting snow reports. Okay. Human observers are huge during the event, letting us know, hey, I'm up at Netherland, I've already got 18 inches of snow. Radar barely sees Netherland, so we wouldn't know there's going to be that much snow up there. We use webcams, and that does help, but nothing quite replaces a human right there looking out his or her window or standing in the snow measuring it for us. So we definitely rely on, we'll go get any information that we can, but that's one of the main sources. Definitely human spotters. For one thing that's going to be pretty important here is how is travel going to behave tomorrow? And one of the things that we use is something developed at NCAR, originally developed at NCAR. That's MDSS. You guys see in the screen? We love this because when we support, two of our most core partners are Denver National Airport and CDOT, Department of Transportation. They need to know, when's it going to stick to the roadways? And if you're looking today, I mean, it's cloudy and cold out there, right? But some of these road temperatures, just because March sun angle and just it's absorbing a lot of heat, it's 50 degrees in a lot of spots, mid 40s to upper 50s on a day like today with heavy overcast. Temperatures have warmed up quite a bit. So armed with this information, and we also get runway temperatures from another MDSS that NCAR originally did the groundwork on. We also get runway temperatures so we can help DIA figure out how much snow might fall on the runways. That's one of the roles we do. But tomorrow, this is going to be a really big deal. Looking at this page is going to be very important tomorrow, because as it stands now, unless you're up in Fort Collins where snow rates could be a little heavier, when you get really light snow throughout the day, especially middle of the day, it's mid-March, the road temperatures are still going to be warm enough. They're just going to stay wet. At least that's what we think is going to happen tomorrow. We're going to be monitoring this page very closely to make sure that our initial thoughts are correct. But because we're seeing warm road temperatures today, we expect overcast and similarly cool temperatures tomorrow, yet the roads are still warm. we've begun messaging that maybe travel won't be as bad until after 3, 4, 5 p.m. on Saturday, because that's when road temperatures drop and the snow rates pick up. So very valuable resource. We're thankful that NCAR did the background research on it, and we have access to it. So this is great.
All right. So that's a couple questions that had come in. One, just real quick, what were the icons on that map of the highways? We were just wondering if it's little sheep, or I wonder if that's actually some kind of cloud.
It's there. Let me. I won't bring it up, but there's actually webcams. Those are little webcam images, and I did forget to mention that. We rely heavily on CDOT's webcams. This particular program that I'm not showing now, but this program has little icons that we can click on and see what the conditions are on that road surface in real time.
Okay. How do you get the temperature?
Temperature, they have temperature sensors at each of those points. Okay. I think they're CDOT's temperatures. Don't quote me on that though.
Yes, I'll jump in. A couple people have asked. We're recording this, and we'll end up putting this onto the Collabs page. And anyone who registered for this, if we have your emails, we can send you a prompt. But we'll make a short news page and put this recording up there. Okay. Also, how about do you use this acronym? Do you use the MPing reports?
Yes. MPing is we use MPing a lot more in severe convective season, because then we're getting reports of, see, it's hard to tell the difference between really heavy rain that's mixed with tiny bits of hail and larger hail. So MPing, you're right under the core of that storm. You've got an app on your phone. You're seeing the golf ball of hail hit you. You can send that right in. Or maybe you're under a storm that looks pretty severe to us, but you're only getting heavy rain. Send it to us on your mobile app, heavy rain.
What is that MPing? What's MPing stand for?
Oh my gosh, it's a precipitation identification. I don't know the rest of it, but the NOAA lab in Norman, National Severe Storms Lab, in a partnership with OU, I believe, built an app that lets each person, it's geolocated, so whatever precipitation type is hitting them, they can just report it with two touches of a button, and then it gets to a database, it gets into our system, so we're seeing it. For snow, we're kind of sure that it's snow that's falling. So what we really want is the snow depth and how hard it's snowing. MPing doesn't really, I don't think it has that type of capability. So for winter storms, we prefer if people just call us, take a picture of it, tweet it at us, however you want to do that. Okay. But gosh, in convective weather, MPing is very useful.
All right. Well, Paul, thank you. We're over the time that we had allocated here. I wonder, could you leave us then with any last thought, almost what should we be watching for in terms of information sourcing? Of course, people can go to the website that you described, but what should we have on our minds as the next 24, 48 hours are progressing, and where should we keep referring to get the best information?
Well, I mean, the selfish, I'll say visit our website, that winter page that I showed you. We're going to have the latest and greatest information. We will only hype the storm if it's warranted, if we feel like something really big is going to happen. And our main concern is that everyone stays safe. Stay off the roads if it's hammering down where you are, that type of thing. But yeah, don't be surprised if amounts get lessened from Denver southeast. That's just the way the models are trending. And a lot of those nuances are lost on, the broader general public. They see these big totals 4 days out, and that's burned into their heads. And I don't know that they hear or look for, okay, there's a lot of uncertainty 4 days out. Things are definitely going to change as we get closer. And now things are changing. That's our biggest challenge in the National Weather Service, is messaging to the broader community, how things are changing, and that some areas really are going to get exactly what we said 5 days ago, like 4 columns, like the foothills. Some areas may get a little bit less than that, and the trends are headed in that direction. It's a big ship we have to steer, especially when it's all been out on social media. But just, if you want a forecast with not the hype, we're giving you our best bet every single time. That's what we get on our webpage.
Okay. All right. Well, thanks, everyone. And again, we've been listening to Paul Schlatter, and he is the Science and Operations Officer at the National Weather Service office in Boulder. And I'm Dan Powers, Director of Collabs. Thanks everyone for making time. We will put this video up onto our website later on this afternoon. I'll be sending out a reminder by social media, I think over the course of the weekend as the snow falls. People will be re-interested in watching this and hearing some of the resources that you mentioned in there. I think, Paul, we can particularly try to prompt people to become like a citizen observer and provide info to you. That's great. That's a resource I'm not sure most people would know that they could be a resource. And thanks for all you're doing. We appreciate having smart people and scientists looking at our atmosphere and understanding the weather, helping us prepare. This is important.
Yep. Thank you. Happy to be here, and thanks for having me.
All right. Thanks, everybody. All right. We'll end this, and I'll be in touch. Bye-bye.